In the graph, you can see the maximum points. What are the minimum points? We can see that this is the minimum point and this is the minimum point. Absolute maxima means or global maxima means the point which is at the highest in the graph. Same goes for the global minima, global maximum. And what all points are below the top, which means this point will be the local and this point will be the local. Local maxima, local minima. If we will move forward, there is two methods of identifying. First is the derivative test. When it will be local maxima, remember the increasing decreasing function we have done. When the function is moving from positive value to the negative value, okay, then we call the function as local maximum. If we are moving from negative value to the positive value, which means we are heading towards local minimum. So what local maxima says is, if we are moving from positive to negative, this point is the local maximum. And if negative to positive is the local minimum. Same concept. If we are moving from positive to negative, then this point is the local maxima point. If we are moving from negative to positive, this point is the local minima point. So if we are moving from positive to the negative, then this particular point is the local maximum. If we are moving from negative to positive, this particular point is the local minimum. What is point of inflection? Suppose this is the point minus infinity, infinity. And suppose there is a point here that is called 2. If signs are not changing, suppose this is also negative, this is also negative, which means 2 is the point of inflection. We will straight away move to questions. What will be the differentiation part of it? F dash x, 3x squared minus 3. 3x squared minus 3. Second step is we will find the x value. 3 is taken common. This is x squared minus 1 is equal to 0. 0 divided by 3 will be 0 itself. X square is equal to 1. Square
Plus
thing is
one.
given plus minus 1. X value is plus minus 1. Okay. Now I am simply drawing the number line. See here. Number line, infinity, minus infinity. Two x values are there. So I'm writing here minus 1 plus 1. 1, region number 2 and region number 3. Select any one value from region number 1, minus 2. Substitute here f dash x. What is the number coming as? What number is coming? Positive or negative? F dash x, f dash minus 2, not x. So 3 times minus 2 whole squared minus 3. 3 times minus 2 squared is 4. 3 fours are. Answer is, so it is
9.
positive. Correct? This
Yeah.
is greater than 0. Greater than 0 means this part, region number 1 is coming as positive. Okay. Now 0. Substitute in the f dash x, negative number is coming, which means this part is coming as negative. Then what? Third region. Select the third region, any number. So with 2. Okay. Substitute. Answer is greater than 0, less than 0. Greater than 0. Now if we will focus, okay, what statement we have written for local maxima? Positive goes to negative. From here, can we see positive is going to negative? Which means what is the point of local maxima here? X is equal to minus 1, we are getting local maxima. Okay, if the
Uh,
f dash x change sign from negative to positive. So from
yes.
where we are seeing the change, sign change?
At
Negative
x
to
equal to
positive.
1.
At x is equal to which value? At x is equal to 1, we are seeing the point. So we will write here at x is equal to positive 1, we are getting local minima or not. And so if x is minus 1, what will be y value? Substitute here x as minus 1. Same way, substitute x as plus 1. If we substitute here, this is basically what? This is f of x is basically what? This is y value only. If we are substituting x as minus 1, we will get the first coordinate, at which we will get local maxima. We are substituting first thing minus 1 in the function to get the y value, then positive 1 to get the y value. What is minus 1 cubed? Minus 3 times minus 1 will be what? Will it not be plus 3? And plus 3 is already there. So when x is minus 1, y is 5. So local maxima is at point minus 1 comma 5 or not. This will be our final answer. Local maxima is at point minus 1 comma 5. Same way, talk about the plus 1 point. So what will be the local minima point? 1 comma 1. Understood or not? Till this particular point, same what we have done in increasing and decreasing functions. Now from here we have to identify the point is moving from positive to negative or negative to positive, and that will specify our local maxima, local minima, x point. Once you get the x points, substitute it in the function to get the y value, to get the coordinates. Now with the help of graph, let's try to understand. Basically this is what f dash x greater than 0. F dash x is less than 0. So this is negative only. If we are moving from positive to negative, this is the maxima point or not? This point, maxima point. Simple. Now again, till here it is negative only. Till here this is positive. So if we are moving from negative to positive, the answer is minima. So now one more question we can do. Same concept. Second derivative test. First we will find the f dash x. Then f dash x is equal to 0. We will find the x value. Simple. Let's try with the question. So what is the first step? Differentiate the function and tell me what is coming.
12x cubed plus 12x squared minus 24x.
Okay. Gerard dash x is equal to 0. So 12x cubed plus 12x squared minus 24x is equal to 0. Okay, can take 12x common. What will be in x squared plus? Then factorize this thing. 12 will be gone to the 0. So 0 divided by 12 will be 0 itself. So 1 is x. If you will factorize, you will get something like this. What are the values? Fully factorize x squared plus x minus 2. X minus 1 and x plus 2. So what will be the three values of x? Can be 0 also. X can be 1 also. X can be minus 2 also. Please confirm. Here everything is same. Now it's time to find the double derivative. Double derivative means this function we have to differentiate one more time. F double dash x. Now double differentiation of the already differentiated function. Yes, it is 6x squared, then
Minus 24.
okay. Now what is the step saying? Whatever value we have got, suppose at x is equal to 0. We have to substitute this 0 here. Let's do the first step. So what we will write? We will write f double dash 0. What?
So we'll get minus 24.
Minus 24. Is it greater than 0 or less than 0, Gerard?
Less than 0.
Less than 0. If double derivative is less than 0, what question is saying? See this part, basic part. If f double dash x is less than 0, it will be the point of local maximum. Always remember, in double derivative test, if opposite happens, for negative we will get maxima, for positive we will get minima. Now you will tell me at x is equal to 1, what is the value? At x is equal to 1, what is the value for f double dash 1? In this function, substitute 1. What answer we will get? 36. So whether 36 is greater than 0, less than 0.
Greater, so it will be minimum.
So this point will be called as the minimum. No space for local, so I'm not writing local, okay? All right. At x is equal to minus 2. What will be f double dash of minus 2? Substitute minus 2 here. Solve it. What will be coming? 36 times minus 2 the
144.
whole square, that will be 4 minus
72.
48 minus. So answer is coming as 72. 72 is greater than 0, less than 0. So this will be the point for minima. So 3x value we got, we substituted all the 3x value in the double derivative function. If positive value is coming, it is minima. If negative value is coming, it is maximum. Now, end task is to find the y values for all. At x is equal to 0, what is the y value? At x is equal to 1, what is the y value? At x is equal to minus 2, what is the y value? See the function? Main function we have to substitute to get the y value. So what is the y value coming as? For 0, I think it's easy. What is the y value for 0? 12. So we will write here at x is equal to 0, comma, y is equal to 12, and this is the point for local.
Maximum.
At other points, we are getting local minimum for both these things. Okay, what is the y value here when x is equal to 1? 7, correct. Okay. And for the final thing, minus 2, x is equal to minus 2. What is the y value? Minus 20. If suppose f double dash value after substituting x value, it is coming equal to 0, not greater than 0, not less than 0. Then we will move to the first derivative test. See here what it's said. If suppose the test fails, if the double dash value is coming as 0, then we will go back to the first derivative test. We will draw the number line. From positive to negative, it will be maximum. Negative to positive, it will be minimum. Only condition when double derivative is equal to 0, then only we will move to the first derivative test. Now, next part, final question for the day. If two positive numbers whose sum is 15, sum of square is minimum, what will be the answer? Suppose graph is like this. 0 comma 12 is where? Suppose this is 0 comma 12. This is 12, so 0 comma 12 is like this. Graph is moving back from here. Possible? This is 1 comma 7. Possible, it can be local minima. Suppose it is going like this. So this is minus 2 comma minus 20. This is a local minima also because it is the bottom point. So graph is looking like this for this particular question. Minus 2 comma minus 20 local minima, 0 comma 12 local maxima, and again graph is moving up from here. 1 comma 7 is the local minima. Now clear? Now, this one. First tell me what should I write? X plus square of the numbers is minimum. So x squared plus y squared, this is said as minimum. Now, if you want the terms to be in terms of x, what we will do? Simple thing, x is equal to 15 minus y. Minimum means what? Positive. Okay. Can we write this as slightly greater than 0? Minimum. Now try to find out the value for y. Substitute here 15 minus y the whole squared plus y squared is slightly greater than 0. This is called minimum. Quickly find out the y value. This will come as 225 minus 30y. Then this will be what? Plus y squared. Plus y squared is greater than 0. So this will become what? 2y squared minus 30y plus 225 is greater than 0. Now what we can do? We have to find the y value. One thing. So for this function, the double derivative will be equal to 0. Sum of the square is given as this now. This is the sum of square. So let's represent this with s is equal to x squared plus y squared. Minimum conditions comes when double derivative s double dash is greater than 0. All right. So from here, this particular part is greater than 0. We will not take from here. This is basically what? This is basically s only. Find the first derivative for this. This is S, this is S, this is S. Find the first derivative, D dash or S dash. What is this answer? 4y minus 30. What will be the threshold point? If we substitute this S dash is equal to 0. All the times we do this thing, first derivative equal to 0. So if I am substituting S dash equals to 0, what is the y value coming? 4y minus 30 is equal to 0. What is the y value? 15 by 2. Okay. Y value is 15 by 2. What will be x value then? Substitute here. What will be the x value? If y is 15 by 2, what is the x value? 15 by 2. Now, if we want to find out the double derivative, s double dash, 4. 4 is greater than 0 or less than 0.
Greater than 0.
This is minimum. So what is the point basically? What we have to find? We have to find the two numbers. So the two numbers are what?
15.
Correct. 15 by 2 and 15 by 2. So this will be our final answer.